What's essentially the business model of many of the startups here in Berlin is customization. So it has to be personal, it has to get to what you're interested in, and in many cases it's customization, but in the end, what's most important for most web application developer is how to serve the right ads to the right people, right? So, because that's where many of you make your money. Okay, so it needs to be personalized. And how do we do that? So what I did here is kind of create a rule book which says, okay, what do you need to do for your application to fulfill all these promises? The first thing is we need to have the DNS requests mapped to an IP address or a CNAME and an IP address and so on and so forth. So make sure that your requests get to the front door of your application and the application sees it at all. We have a DNS service called Route 53, and for most people DNS is kind of boring. So when I created my own domain for my private email and some other stuff, I tend to do this myself. I got to a domain provider, paid my €7.14 per year, and then got my DNS entries. And that's fine for something private, but if you want to do it professionally, it gets more interesting. And first of all, you need a DNS service that's 100% available. DNS is not only an issue about uptime, about serving your requests. DNS also has the interesting feature that it's the trust for your application. There are several attacks in the past where somebody get hold of a DNS registration of a domain and then just put up the stuff somewhere else. Okay, so now we can service our DNS request. Next thing is we have the application and the IP address is resolved, we get to the application, so we need to service that. And then it goes to the web front-end servers and to the load balancer. And that's the next thing. First of all, yes, we do have great data centers and so on. Always assume everything that can break does break. So yes, each of our instances is commodity-based, but still a good instance. It can break anytime. Anytime you can lose your machine. If you really want to be 100% sure, go to multiple regions. In most cases, customers go to multiple regions for different purposes. So if you serve customers here in Europe and in the US, so if you're a typical web-only startup that really wants to go worldwide, it makes a lot of sense to duplicate the exact same architecture with the exact same script, so like Thomas said before, with the SHEP receipt and so on, in Japan, in the US, in South America. The good thing about it is you can really use the exact same scripts, with the only thing you need to exchange is the region code. And that's great, because if you realize that you created, let's say, the latest and greatest cat video animation service, and then, to your own surprise, realize that this is very popular in Japan, which kind of self-fulfilling prophecy, right? And then you really want to have IT infrastructure to serve your Japanese customers better. It's really hard to do, to go to a hosting provider in Japan and rent servers there, right? But with AWS, you have the advantage of really doing the same thing here. So, great, multiple regions. Multiple web servers distributed, great. And then we have our typical problem, which is the database. So what we did for you is create a service called Relational Database Service, which is a managed database. First of all, this makes developers happy. Let me tell you a little story about this. You all know the Dilbert comic, right? The author of the Dilbert comic, Scott Adams, wrote a book aimed at enterprise people. And one of the chapters in the book was about how do I make myself irreplaceable at my company, with the purpose of not doing a lot of work, but still being there without being fired. And his idea about this was, okay, you need to do something which is always needed and is so boring that most people would rather shoot themselves than do it. And his examples were tax law and database administration. So you see how much developers love database administration. And that's why we created a managed service for you, which has the great advantage, at least as long as you're using MySQL or Oracle, that we automatically do for you the distribution across multiple availability zones. There's a feature called multi-AZ, which essentially creates a synchronous mirror of your database in a separate availability zone, which gives you three things in one place. First of all, if the availability zone goes down, you still have your database. Second of all, if your database server itself goes down, which is way more likely than the whole availability zone going down, you still have your database. And third of all, if you want to scale up or down your database, because scaling out with a relational database is not easy to do, but scaling up and down with bigger or smaller instances is easier to do. And you can do this with RDS and say, I want to have a bigger instance now during the day and a smaller instance to save money at night. What happens if you have multi-AZ? It flips over the database, so it's offline for a few seconds, 20, 30, 40 seconds, I think. Did you ever measure that? Something around that number. Then your database is online. Then it creates the bigger instance in point 1 and flips it back again, so you have your database scale up and down with a small window of downtime. It's still a window of downtime, but it's in the high number of seconds area and not in the 20 minutes area, which you usually would have. Okay, great. So we have served all web requests. Great. Next thing, performance. If you're in Germany, probably Ireland is the fastest region for you. And if you're in the US, probably one of the US regions is the fastest region. But then, especially in Berlin, we have some startups which are focused on third world countries. And if you're in India, then it gets interesting. What's the fastest region? The interesting thing is it really depends on your ISP. You can have being here in Mumbai in one building, and the next region is Ireland, from a performance point. And then you can have somebody across the street with a different ISP, and the fastest region is Singapore. Content delivery network. Content delivery, what's a content delivery network? It's essentially a cache of your data nearer to the user. So your servers are sitting in Ireland. Your users are sitting here in Berlin. So what the content delivery network essentially does is somebody is getting to your page, and the page has lots of static elements. Pictures, videos, CSS files, JavaScript files, and so on and so forth. And maybe some static HTML too. So first user gets there, gets the call from Ireland, it downloads to a content delivery network location, in this case probably one of the locations in Frankfurt, and it's serviced. Next user comes, gets the request, gets the static cached content from the Frankfurt location, it never gets to your server. So it's faster for the user. This also works for dynamic content, up to a point. Of course, you don't want to have your highly dynamic PHP, no, we are at the Ruby conference, so your highly dynamic Ruby site here cached for an hour. Because then it takes away a little bit of the dynamicity, right? But it's still worthwhile to cache, and we can do all of that with a single CNAME, so with a single entry. So the obvious advantage of a content delivery network like CloudFront is that the latency for your user gets smaller, and so things are getting faster. The not so obvious advantage is it takes away load from your servers, because everything that's cached to the content delivery network is not answered by your servers. What DynamoDB is a typical NoSQL database. So you have a key, what we call a hash key. You may have a second key, what we call a range key. So imagine hash key is customer ID, range key is date of order or something. And then you have an arbitrary number of properties, columns, attributes, whatever you want to call it, which have the type of binary, integer, string, or set of binary, set of string, set of integer. And that's all. You write these, you read these, that's it. It's the Royal Opera House of London. Opera house, physical house. Do they need to scale? Most of the time, no. Because I don't know how many seats they have, like 2,000 or something. They need to sell them out once or twice a day. Doesn't sound like a lot of performance you need. Trouble is, they have some world stars. And yes, there are world stars in opera. And when the tickets for the next quarter go on sale, they have sometimes more than 1,000 times the number of requests for tickets than they have tickets for these stars. And all of this happens within a 10-minute interval around the tickets going on sale. Because everybody knows if I come an hour later, these are gone. So they need to scale up their database and their performance 4 times a year for about 10 minutes. That's what they can do here. Okay, so scaling up and down is possible, and don't forget you don't have to keep an instance type forever. So you can say, okay, I'm only having heavy usage during the evening hours because I'm consumer-oriented, and maybe during Saturday, and all the rest of the time I need smaller instances. So that's good. So what can you do with auto-scaling? You essentially can do 4 things. One is manually. So you can just issue a command and say, please add 4 of my web servers from the web server template. You have to give it a template, which we call AMI, so Amazon Machine Image. Please add 4 of these web servers to my phone. Where it gets interesting is by policy. So what you can say is, okay, I want to add more instances whenever the average CPU usage of my web front-end servers is above 60% for more than 10 minutes. Something like this. And then again, I want to remove instances when the average CPU usage of my instances is below 30% for the last 30 minutes maybe, because you pay by the hour, you don't want to provision and deprovision instances more than once an hour. With EBS, you can say, I want to have a provision capacity of I/O operations per second. And mostly this is for relational databases. But there are also other use cases for that. Up to 4,000 per volume. And then you can also stripe. So you can use your Linux volume manager and do striping across multiple of these. So you can even get higher performance. So while latency to your storage is still an issue, doing lots of operations against the storage is not anymore with provisioned IOPS. So you can, as long as you're parallelized, so not have a serial disk request queue, if you have a parallel one, you can get a pretty good throughput of your disks. Or, again, you use DynamoDB. There you just say, provision the throughput, provision the write operations per second, provision the read operations per second, that's it. Workflow. If you have many different processes, many different applications that you need to orchestrate, workflow service may help you. Cloud search, so the ability to do a search engine. It's a great feature. Currently, it only has one drawback, it's only English. So it works great if you're searching English content, but unfortunately no support for German yet. EMR, Hadoop. Everybody's doing Hadoop on Amazon Web Services, but EMR gives you a managed Hadoop implementation. So again, you don't need to know how to build a Hadoop cluster. You don't need to know how to shuffle around things if one server breaks down, if one disk breaks down, and so on and so forth. These are many advantages, but the biggest advantage of EMR is the ability to use spot instances. And I will talk about spot instances later, so let's add that. So, okay. Automate management. Yeah, exactly. We were talking about that. So, we heard about servers as software, or what I would say, servers as a programmable resource. So we do have APIs for next to every interesting programming language in the world. So we do have .NET, PHP, Ruby, Python, I always use the Python command line and not the command line tools because I find it more intuitive to use Python and Boto than to use all the command line tools. And Python has a nice interactive console. So always think about programming all your resources and not about clicking and pointing at the console. And then we have management tools. We talked about OpsWorks, so the environment that uses Chef to deploy the servers. But if you want to start with OpsWorks, you don't need to know Chef. So it's an easy start. You can click all the stuff together, and there are pre-generated Chef recipes for what you want to do. And later on, you can start changing these recipes and adding stuff to it and something. Another interesting thing about OpsWorks is the development team is here in Berlin, which I find great to have these guys around. CloudFormation does something similar, but has a totally different approach of doing things. Because for all your application, you're writing exactly one thing, which is a JSON file. So all the stack with everything you have in there is one big JSON file, which scares a lot of people, for good reason, but it's very powerful because it doesn't leave any flexibility and any kind of interpretation. It's just that you can check this into Git or whatever your source control system is, compare it, match it, and auto-create it with JSON. One thing is, don't try to start this from scratch. Always use example and start from there because it's just too hard to do if you really want to do it manually. And Beanstalk, finally, is kind of a platform as a service version, so it's intended for the developer that wants to deploy directly from Eclipse or from Visual Studio if you're doing Windows or all that stuff. So it's really, you upload the package and all the rest, all the configuration, including auto-scaling and something like this is done for you. Bootstrapping. So we were talking about this before. Whenever an instance starts, make sure the instance has a place to go to find out who she is. So some kind of central configuration point to know stuff from. I talked about autoscaling, I talked about CloudWatch, so that's the eventing system that tells you about the performance of your stuff. And the good thing about CloudWatch is that you can have something called an alarm, and an alarm is more intended for the administrator to see what's happening, but an alarm can again start code and do something interesting with the alarm and do some mitigation of errors and something like that. We heard about Chaos Monkey, so the Netflix tool that randomly goes around and turns off services to check if the developers are developing correctly. Because after all, I said that everything can fail. For testing, it doesn't fail often enough by itself. So you really need to do something that you can test all the failure cases. And finally, leverage unique cloud properties. Leverage the fact that you can have all the different instances types. Leverage the fact that you can have different pricing models. No developer likes to think about pricing and about money, unless he's founder. But it's really interesting. Spot instances can get you up to 80% less money for the same instance type. You place a bid and say, I want to pay only 25% of the price for this instance. And as soon as the spot price goes below that, you get your instance. Trouble is, as soon as the spot price goes up again, we take away your instance. So it's great for a batch worker. It's interesting for the architect because he really needs to deal with the fact that the instance can go away anytime, but it can save you a lot of money. EMR, I was talking about this, integrates great with spot instances, cluster compute instance. So if you want to have something like mechanical engineering that needs low latency networking in between multiple instances, do that with cluster compute instances because they have a dedicated 10 gig Ethernet interface between all the instances in a so-called placement group. And that's it.